So good, some students had the right answer here. I just had to get rid of the filter. So now I do statistics protocol hierarchy, and now you see all the protocols used here: Ethernet, TLS, SSH, and other ones, and you just should know from your Net Plus information which ones of these are encrypted. And you'll find there's only one encrypted protocol that sends a significant amount of data. And after you've got that, then you can find the tool doing it, and I'm just going to demonstrate. Now it's sending data over 8443, and I'll just point out this one because it's where a lot of people get confused. If you go here, if you look at TLS, Transport Layer Security, there's 52 packets, so quite a lot of data was sent there. Now if you right-click and apply this as a filter, selected, then you'll see the packets, and you can see here it is sending data from local high-numbered local port to 8443, and that should be a clue. 443 is HTTPS. 8443 is something you might use for a fake TLS. So if you want to find out how did this happen, how did they set up a encrypted server that appears to be TLS on an unusual port on my network, they issued a command line command including this port number. So you can find it with this very useful display filter. Frame contains 8443. This is where those strings will be literally, and there are various packets that have that string in them. And so you'll see, if you look at the time, something happened around 97 seconds, something happened at 1118 seconds, and something happened down here at 1800 seconds. So there were 3 conversations, including this number. Now, if I look at this one, follow TCP stream, I see just some web page loading, nothing very exciting. So that's somewhere in this web page that number appears, but that's not the interesting stuff. So let me go back to frame contains 8443, enter, and let's try the stuff at 1118 seconds. Some other conversation happened here. If I follow TCP stream, this is also looks like just a web page loading. If I drag this down, nothing more exciting than just web pages loading appears, so that also looks not much good. So let's go back to 8443. And if I go to the next one, which is around 1800 here, now I'm getting the attack. The attacker got a shell inside my network, and here they are executing things. ID to find out who they are, their root, uname -a to find the version of Linux that's running, IP addresses. The red shows the attacker's commands, the blue is the response. This is standard, by the way. This data you typically collect from a host. You do the running processes, and then you do netstat to see established connections. And here, they downloaded, they started a listening port on 3N337 and fed it into SOCAT, which is a utility you can use to make network connections. And down here, they generated a secret key with OpenSSL, preparing to do HTTPS. And then here, they made a new secret key, and here they put it in a privacy encoded mail file, which is the way it has to be. And down here, this is the one that creates the HTTPS server. This is listening on 8443 using SOCAT, which is a tool that can do this, and using that certificate. This is an HTTPS server with a user-generated certificate so they can have encrypted communications here. But you'll see they sent the SOCAT tool over the network unencrypted, and they sent the certificate over the network unencrypted. So you can steal the key and decrypt this communication. And so that's why it's a really good thing to play with. Here's where you see the actual steps of the attacker. And from that you can reconstruct what they did, and you can answer a whole bunch of flag questions here about it. So that's a fun one for the more advanced students that have had their Net Plus. All right, let me check for comments in the Twitch. I mentioned 106, yeah, good. People say Professor Bornstein is good. That's good. Yeah, and glad you guys figured that out. Good. All right, so I'm going to stop this recording, and